Good morning, good afternoon. Slavnica Miss Matei again here. We'll talk about solving a quadratic equation. What does it mean to solve a quadratic equation? It seems to me that you gave me here the graph of a quadratic function. Is that correct?
That's right. This is a parabola, and what I'd like to emphasize here is that the parabola consists of infinite number of points. However, some of them are more important than others.
Okay.
So let's get started with the point that is the lowest point on the parabola, and we know that we call that point vertex. It can be maximum or minimum.
Okay.
Let's talk about y-intercept on a parabola. That is the point on the y-axis.
I know something important about this point.
Yeah, the x-coordinate is always 0.
X-coordinate is 0, and in this case, the y-coordinate is -6.
That's correct. And then we have 2 points that are on the x-axis, and we call them x-intercepts.
We call them x-intercepts. And in this case, they are most likely -1 and 6. What's specific to them is that the y-coordinate is
0.
0.
Okay. So what does it really mean to solve a quadratic equation is that we are looking for x-intercepts only.
Okay. So we are looking for x-intercepts. To solve a quadratic equation means to make your y equals to 0, which basically happens for the x-intercept. So solving a quadratic equation means finding the x-intercept.
That's correct. And we will be looking into several methods of finding x-intercept, and we will start with the easiest one, and that is solving by graph. So simply look at the graph and see what are the x-intercepts. So Ms. Matei, can you tell me what are the x-intercepts in the first graph?
Let's see. I can see this one. It's quite clear. The x-intercept is -1. So my first solution of the equation is x equals -1. The second one seems a little bit harder to read. It's somewhere around 2.5. That tells me that maybe sometimes there are situations where graphing is not enough to solve an equation. I might need more precise. But for now, I am happy with the solution I got from graph.
That's right. So when you look at the second graph, how many x-intercepts do you have?
I see 1. The vertex is my x-intercept, right?
That's correct.
Okay, so it's in this case it's 3 and 0. So the x that I'm looking for is x equals 3.
That's correct. And then you can have a situation like the first one. And what does it mean? Do you have any x-intercepts?
No x-intercepts. My graph does not cross the x-axis, so I do not have any x-intercepts. So the idea was take your quadratic function, graph it, and read your x-intercepts.
That's correct. Now, the second method that we will explore today is to find x-intercepts. We've learned that we can factor the equation, and then we will solve it by factoring. So, 2 numbers multiplied together will give you -10, added together will give you +3.
So the 2 numbers are
+5
+5
and -2.
You know, I never believe I always have to check. X squared minus 2x plus 5, that is 3x minus 10. Now I believe you.
Good.
So let's attach, this is my function. Let's attach the equation. The equation is where y equals 0, right? So my equation, my quadratic equation is the same thing equals to 0. So that's my function. Let's make sure we emphasize terminology here. And this is my equation. How do I solve it? I want my y to be 0. So it happens when x equals -5 or when x equals
+2.
There you go.
And these are your 2 solutions for the given function.
If I was to graph this would be my x-intercept. Good. One more. Oh, I see a common factor here first, correct?
That's correct.
I take it out, so y will be 2. I need help, you know, I need help with factoring.
So it will be x plus 4 and x minus 3.
I never believe you. X squared plus 4x minus 3x. Yes, now I believe you after I check. So again, that's my function. Let's attach the equation, which means my y is 0, right?
Correct.
So that means x, where is y 0? When x is negative 4 or when x is 3. These are the roots of the equation or the x-intercept.
Or solutions. What happened to that 2 in the front of a bracket?
Well, Miss Lavnika, 2 can never be 0, right?
That's correct.
Okay, so I didn't need to worry about that too.
Good. So the last solution that we would like to produce will be, again, solving by factoring. And for a good practice, we will look into a decomposition method.
Okay.
So we are looking for two numbers multiplied together will get negative 30. Added together will give you 13.
Okay.
So I think it's a negative 10 and no, it will be negative 15, positive 15 and 2.
Positive 15 and 2 and negative.
Negative 2.
Right.
And when I add 15 and negative 2, I'll get 13. So
yes.
Let's do the decomposition.
Let's do that. 3x squared plus 15x minus 2x. This is my old 13x and minus 10. Oh, we've done that so many times. Look how fast I am now. 3x, x plus 5,
Yep.
minus 2, x plus 5.
That's correct.
Lucky again. X plus 5 is a common factor from my two terms. Done. What do I want? That's my function, so I need my
equation, and that means your y value will be 0.
My y value.
And you will solve that equation by factoring.
X equals negative 5 from the first one, or x equals
2/3 from the second one, and we'll keep it as it is. Two solutions, two x-intercepts.
two solutions, two x-intercept.
And we are done.